Again, welcome to Data Structure and Algorithm, CS435 class. In this lectures, we're going to discuss about stack data structure, one of the fundamental data structure. So our main objective is to learn about stacks. Also, we are going to examine various stack operations. We're also going to learn how to implement a stack as an array, and also how to implement a stack as a linked list. Now, the difference between them is that array is a static data structure, which means the size is fixed. Linked list is dynamic, which means the size is not fixed. So again, we'll go detail about the difference between array implementation and also linked list implementation of stack. And also we're going to discover some few stack operations. So first we start with what is a stack. Here we say a stack is a list of homogeneous elements, which means a stack must have the same data type. And also the addition and deletion of elements from the stack must occur at the top of the stack. So which means the entrance and exit is only at one point, which is the top of the stack. So computers normally will use stacks to implement method calls. Also operating system use stack for method calls also. Also stack are also used to convert recursive algorithm into non-recursive algorithm, especially recursive algorithm that are not a tail recursive. So let's see one example of stacks here. So in the real world here, we have stack of coins. We have stack of trays. Now, if I want to pick any coin, and again, we can pick it anywhere, but we have to move the top up a little bit to pick underneath. But in computer science, stack implementation means if I want to pick the last coin, I need to remove all the the coins on top of it. If I want to remove the second coin, then I have to remove the first coin before the second. So that's why the data structure of stack we normally call the LIFO. The last in is the first out. So the last items that go into a stack will be the first item to come out. The same thing applies to a stack of trays. Also, we have stack of books here. Again, anytime I'm going to push a book, I'll place it on top of the stack of the books. So as we said earlier, again, last in, first out, or last input, first output, LIFO, and that's stack implementation. So we can also use a stack to reverse a string or a value, because the first item that goes into the stack will be the last item. So if I want to reverse, let's say digit 312, first of all, 3 is the first digit, so that will go in the stack first. But when they are coming out, 3 will be the last item to come. So automatically we are going to reverse it. These are some of the stack operations. So for example, we can push an item into a stack. We can pop an item from the stack. Also, we can pick an item at the top of the stack. Pick means we want to know the item on top of the stack, but we are not going to remove it. So this is the push, pop, and pick. Now, if it's array implementation, we need to check if the stack is full, if there's a space before we push an item. But in a linked list implementation, again, this dynamically allocates a memory space, which means when the program is running, it can allocate a memory space. So we don't need to check if the stack is full or there's a space. So this is a stack operation. For example, we push the box A, so we have only one element. Next, we push box B. We have 2 elements now. Next, we push box C. We have 3 elements. Now, next operation is to pick at the top element. Now, pick at the top element, the stack didn't change. We still have 3 items. We just want to see what is on top of the stack, which is C. Next, we push D. So now we have 4 elements. Now, when we pop the stack, D will be out because D is on top of the stack. So now we have A, B, C. C is on top now. So basically, this is how stack operation works. Now, this is a stack ADT. So these are the stack of methods or the operations. First, we can initialize a stack. And also the plus here means public. So all the methods here are public. This is a UML diagram, class diagram. We have the class name, which is stack ADT. This is interface, so we don't need variables or data members for the stack. Or we call the instant variables. We don't need it because this is stack ADT. So first operation is to initialize stack. We can also check if stack is empty. So it's empty stack, we check if a stack is empty, and it will return true or it will return false if there's no space. We can also check if a stack is full. So it's full stack means checking if there's a space or not. Then we can push an item into a stack. When we are pushing, the returning value for the method will be void because when we push an item, we are not expecting a returning value. Also, the same thing applying to pick. We can check the element on top of the stack, so we have to return it. Pop, we remove an item from the stack. We don't return it because when we remove it, we deallocate the memory space. We basically throw it away. So let's go through the stack class, data members, and also the operations, which will represent the methods here. So first, we are going to do the array implementation. So in array implementation, when we're adding an element to a full stack, we know we are going to have an exception. Also, the same thing, if we remove an item from empty stack, we are going to also have an exception or generate errors. And those two errors are stack overflow exception. This is a built-in exception class, which is the runtime exception. We have it in Java. This is again Java implementation course of data structure. So we also have a stack underflow. Underflow will occur when we're trying to remove an item from empty stack. Overflow means we're trying to add or push an item into a stack that is already full. There's no space. So we have a stack exception, extend runtime exception. Then we have the stack overflow exception, extend the stack exception. Again, the concept, the keyword extend is the inheritance. And then also stack underflow exception extends to stack exception also. So the stack exception will be the parent class or the base class. And the runtime exception is the main base class. So implementation of stack as an array. So the array implementing a stack is an array of a reference variable. So here we need to create an array or declare an array with a specific size. And also each element of the stack can be assigned to an array slot, which is our array index. So the top of the stack is the index of the last element added to the stack. So this means if the stack is empty, the index will be -1, because if the index is 0, it means we have an item inside. So to keep track of a top position, we declare a variable called the stack top. And this will be in the stack class, this will be our instance variable, one of the instance variable. So we may also declare the array with a specific size. Those are the two main methods, instant variables that we need. So this is again the stack class. We have the stack top. And also this is array implementation. Our array name is list. The data type is generic T. The T make it possible for us to, when we create the actual stack object in the main method, we can use any data type. Now, if I say the array is int, it means I can't create a stack with a float or double or any data except int. The max stack size is int because that would be the size of the array. The size of the array has to be a whole number, whether 100, 50, 10. And also the stack top is int because it's going to keep track of the index from 0 to whatever the size of the array is. So we have our default constructor, which is called a stack class. The default constructor is a special method that have the same name as the stack name. It doesn't expect no returning type, and also we don't use void. And with that argument means it will initialize the stack to whatever initialization we have for the instant variables. So if you don't have anything, then it will initialize everything to 0. Now we have a second stack class with, again, one argument. So this make it possible for us to create a stack class, the object, and we can, this time the object don't have to be empty. We can specify how many elements in the stack. Now we also have the method for initializing the stack. We also check if the stack is empty, is full, push, pick, and pop. So these are the main methods for stack operation. Again, this is a re-implementation, so we also have the method to check if there's a space in the stack. It's full stack. Now here we create a stack, and this stack size is, again, this is a re-implementation. So the name of the array is list. The size of the array is 100, which means the index will go from 0 to 99. At the moment, the stack top is 4. Why? Because we have 4 elements, A, B, C, D. So the index will be 3, because index always, array index always start from 0, but the stack top will be 4. Stack top will keep track of the number of elements in the stack. So that's why we say if the array index is 0, it means we have 1 item. So the stack top will be 1. So if it's an empty stack, then we can make the stack top a negative value. We can't make it a positive value because array index is from 0 to any positive value. So now let's go through the code one at a time. So first we have the default constructor. The name is the same as the class name, which is called the stack class. Now this default constructor, when we create a new stack object, we need the array. The size is 100. Also, we want to make sure there's nothing in the array, the stack array. So the stack top is 0. We can set the top to any value we want to. Then also we declare our array. So array name is list. And you have a data type for now is T, which is generics. Then we use the new to dynamically allocate the memory space. And the size is 100, max stack size. So this will create an array with a size of 100. So this is our default constructor. Anytime we create an object and we use this constructor, it's going to give us a stack object, array implementation. The size is 100 and there's nothing inside. Now let's look at our second method, which is to initialize stack. Initialize stack concept is almost the same as a default constructor. You can see that here, we want to make sure the stack top is 0. But we use the initialize stack when we create a stack object and we use it for some time. Let's say we push an item, we remove an item, we do some operations. And later we want to use the same stack, but this time we want to make sure the stack is empty. Then we can use the initialize stack, because the constructor is only used when we are creating a new stack object. Initialize stack means we already have the stack. We use it a couple of times. There is data inside, we want to delete it. or want to make sure the stack is empty. So we can call the initialize stack to initialize it. So you can see that we use a for loop. We start the index from 0 to the stack top less, because if the stack is 100, the index will be 0 to 99, and the stack top will be 100. So we say less than 100, so we go from 0 to 99. Then anytime we go through the items, each item we meet, we initialize it to null, which means again, we are deleting all the items. After we finish, we set the stack top to 0 to make sure there's nothing. Next is to check if the stack is empty. So here, to check if a stack is empty, we just want to check if the stack top index or the stack top is equal to 0. If it's equal to 0, it means there's nothing in the stack. So here we are going to return stack top equal to 0. If it's true, then it's empty. If we return false, it means it's not empty. Next, we also check if the stack is full. Again, we are using array implementation. So all we need to do, let's check if the stack top equal to the max stack size. The max stack size is the maximum. And if the max stack size is 100 and the stack top too is 100, that means it's full. The stack top, if it's less than 100, we are going to return false. So that means there's still space. So we just need to return stack top equal to the max stack size. Next, we want to push an item into a stack. Again, this is a re-implementation. So the first thing we do is to check if there's a space in the stack. If there's a space, then we are going to assign the new item to the stack top index. Then we increment the stack top by 1. Because when we push an item there, top will increment by 1. So that's the steps here. It's 3 steps. First, let's check. We call its full stack method to check if there's a space. If there's no space, then we throw the stack overflow exception, and that's it. If there's a space, then we are going to skip this statement. Then we move to the next statement, which means we are assigning a new item to the stack top. Then we increment the stack top. Remember the list, the array name is list. So list stack top. Then we increment the top. So it's 3 steps again. Check if there's a space. If there's no space, stop. If there's a space, assign the new item to the array, which is called the list in this case, at the stack top. Then increment the stack top by 1. Now to pick, the picking means we want to see what is on top of the stack. We are not removing it. So all we need to do is to return the stack top. If we are returning the index, remember, if there's one item, it will be 0, but the stack top will be 1. So which means we are going to return stack top minus 1, because we are following the index here. Index always start from 0 to 99 or to any number. If it's 0 to 9, it means we have the size is 10. So the stack top will be 10 when we reach the last. So here we say if it's empty, of course we can't pick an empty stack. So we throw the stack underflow exception. Other than that, we just return the stack top minus 1, the index position. So next is to pop. Pop means we want to remove the item from the stack. So the first thing we have to check, we don't want to remove an item from empty stack. So otherwise we have underflow, stack underflow exception. So here first we check if the stack is empty. If the stack is empty, then we throw the stack underflow exception and we stop. If the condition is false, then what we do is 2 steps. First of all, we are removing an item from the stack. So we know we only have to insert and also remove from the top of the stack. So first of all, we decrement the stack top by 1. Then we assign none to the stack top. We'll make sure there's nothing on top. So decrement by 1, then assign none. Now we finish with all the stack operations. As we said, the major operation for reimplementation is check it if it's empty, check if there's a space, do your push operation, do your removing, which is the pop operation, and also check what's on top of the stack. Now, there are so many applications. As we said earlier, the most common operating system use stack concept for method calls, or any program, compilers, same concept. One of the application also is called the postfix expressions. We can use the stack to solve postfix expression problem. So let's go through what is a postfix expression. Here we say, let's see how a stack can be used to help us solve the problem of evaluating postfix expressions. Now, a postfix expression is written always with the operator before the operands. So for example, 15 minus 8 is called the infix expression. 15 minus 8 is 7, infix. This is what we know. But we also have what we call the postfix, which means the operands will come first before the operator. So 15, 8 minus, the answer also will give me 7. Now we can use the stack to evaluate this expression. So this example of infix, this is what we know from college algebra: 3 times 4 minus 2 plus 5. We have parentheses, then times 4 divided by 2. Now, in this infix expression is the same as the postfix expression we have here. Since we are doing 3 times 4, we bring 3, 4 first, then times. Now, we know that parentheses have to execute first, plus before minus. So we have 2, 5, then the plus. Then after we do 2 plus 5, 3 times 12, we find the difference of the 2. That's why we have the difference here. Next, we are going to do 4. The answer we get, we multiply by 4. So we have 4 here, then multiplication. Then the answer we get, we divide by 2. So we have 2 division. So the expression here, which is the postfix expression, is the same as infix. Now, this is a very simple example, and we can solve this problem by using a stack operation. And this is the algorithm. So here we say we use a stack as follows to evaluate the postfix expression. First thing we do, we scan the expression from left to right. That's the first step of the algorithm. Scan the expression from left to right. Then when we get a value, or in this case, an operand is accounted, we push it onto the stack. But anytime we come across an operator, then we have to pop top 2 elements on the stack. Then we perform the operation, then we put the item back to the stack. Now, when the expression is exhausted, the value on the stack will be the final result. So let's see an example. Let's say we have 7, 4 minus 3 times 1 and 5 plus division and multiplication. So the first thing I will do, I have 7, 4. I can't do anything. So I'll push 7, 4 into a stack. The next value is -3. I also push it. But when I saw an operator, I'm going to pop the 2 values and find the answer and push them back. So this is multiply. This means I'll get 4 times -3, which is 12. Then I'll push the 12 back. So now we have 7 and -12. Again, 4 times -3 will give me -12. So now we are in 1. We push 1. We get 5. We push 5 into the stack. Now we have a plus. So we are going to pop the 2 first values and do the operation. So this is plus. So it will be 1 plus 5, which will give me 6. Next time we have a division. We pop the 2 values. So we get -12 divided by 6, and that gives us -2. Then we have a multiplication. Then we pop the 2 values, do the operation. So our final answer will be 7 times -2, which will give us -14. So this expression is correct. Also, sometimes this is where we say stack can be used for method call, etc. Also, we can use the stack to check if the postfix expression is correct or wrong. Now, if I keep going and at the end, I have no value, but I still have operator, then the expression is wrong. There's something wrong in the expression. So now we move to the next stage, which is the link implementation of stack. So as we said earlier, arrays is face size. When we create an array or we declare an array, we have to specify the size of the array. The size, we can't change it unless we increase the capacity of the array. For example, I have the array size already, I'm using it for work. Later on, I can multiply the array size by 2, which is at double the size. But during the running process, we cannot change the size. So that's why we say array is static. Now, linked list is dynamic, which means when the program is running, we can allocate a memory space. So dynamically allocate memory space using the reference variables. So linked list is dynamic implementation of stack. Now it's similar to array representation. We still have the stack top. We still have all the stack operations, but the only thing we don't have, we never check if the stack is full, if there's a space. There's no need of space no more because we dynamically allocate memory to the. So this is our linked list implementation. So now we cover linked list already. A linked list normally consists of a node. Each node may have 2 parts, the information part and also the reference. The reference part will be the address to the next node that is pointed to. So for example, here we declare a stack, and then we can see we didn't specify no size. There's no any size of the stack, but we still have to specify the stack top. Now, anytime we dynamically allocate a node and insert it, we have to create it. We create a node and we assign information to it. Then operating system will do the addressing for us. So here, for example, we have a linked list stack with 3 items, A, B, C. So let's see the operations. Now with the default constructor, we set in as we cover linked lists, we know in linked lists, if the linked list is empty and there's no any node, that means the special node, which we call the first node or the head node, is to point to null. So the same concept here. If I have the stack top, assign node to 8, it means there's no any item in the stack. In this case, there's no node in the linked list stack. We can also initialize a stack. The same concept. If I want to initialize a stack to make it empty, I'll make sure the stack top also is null. There's nothing. Then we can also check if stack is empty and also if stack is full. So if stack is empty, we just check if the top is null. Since we said that if we want to initialize the stack to an empty state, we set the null to the stack top. So the same thing, if I want to check if the stack is empty, I'll check if the stack top is null. Normally, we don't check if the stack is full, but this is just clarification. You can see that here we return false because the stack never gets full, so we already said false. Now, to push an item into a stack, a little bit different. As we said earlier in linked lists, if we want to insert a node into a linked list, what we normally do first, we have to create the node. Then we have to assign the data to the node. Then we have to change the pointers and insert the node at the right location based on how we manipulate the pointers. Here is a stack. So we know everything has to come through the top, whether inside or outside, push or pop. So we don't do the manipulation of the pointers to change the place we want. But when we are doing linked list, again, we can insert a node into anywhere we want to in the linked list. That's one of the advantages of linked list. So the first thing we do here, we create our new node. We call it new node. And that's why we use the new keyword dynamically allocate. So the new element and the stack top. So this will create a new node and insert it before the stack top. We have to, only one place we can insert or remove an item in a stack, which is the stack top. So we say stack node, new node, the new node equal to stack node, new element, and the stack top. Then the next step, we assign the new node to the stack top. So set the stack top to point to the top element, because again, when you put a new item in a stack, it has to be at the top. So that's why we set the new node to point, assign to the top. So that's it for the push operation. Create a new node and insert the new node at the top of the stack, or push it at the top of the stack. So pick means we want to check what is on top of the stack. So we still can check if it's empty. So if stack top equal to null, which means if the stack is empty, we throw stack on that for exception. Other than that, we return the stack top.info. Again, this, we know this is linked list, so the variable we use for the information part of the node is called info. So that's why we are using info here. It can be any name. Then to pop the same thing, we're going to check if there's something in the stack. So is the stack top equal to null? Yes, then we throw our stack on that for exception. If no, remember the link is the address section of the node. So before we even use the stack implementation of linked lists, we need to have our node class with the links. So that's where we refer to here, the stack. And also when we are creating the stack node, you see we are using stack node. This is the class of the node. This is the class, because again, this is a stack class. We don't use stack because here I'm creating a new node, so I have to use the node class, which is called the stack node. So in the stack node, we're going to have the instant variable for info as where we put data, and then the link, the address of the node. So that's why here we are saying stack top.link. Remember in linked list, when we call link once, it means we move pointer once. Plus, if I say link, I'm going to delete two nodes. I'll move two nodes out. So here we are saying stack top.link assigned to stack top. So we move one step down. Then we remove the top of the stack. So also in Java, we have the class name stack, which is part of the Java utility package. So we don't need to write all this, checking whether stack is empty, pop, push. We don't need to write all these operations. We have the library file, the package already. So it's called the stack class. So this is the constructor for the class. If you want to check if the stack is empty, we use the method name empty. Again, here, most important, we have to know the method names. We have to use the exact methods here. So push, pick, pop, they are the same. We can also search an element in the stack. So we didn't write that code, but we can also write it, and Java utility package have it also. So this search will return the relative position of the item specified by OBJ, which is our argument object. If I'm searching, the argument will be the item I'm searching. from the top of the stack. If the item is not in the stack, it will return -1. So again, that will be our conclusion of stack. Again, this lecture is based on the theory, the whole foundation of stack data structure in theory. Again, in the class, we're going to have an assignment for the hands-on lab work, and also we may do an example in the class for lab work. So again, wish everybody the best. Thank you. See you in the next lectures.